Hi, this is Andrea Hendricks, and I want to talk to you some about applications of equations of lines, and this is the material that's found in section 7.2 of your text. The focus of this section is to apply the concept of writing equations of lines to real-life situations, and there are going to be two main types of applications that you need to be able to do in this section. The first type is given an initial value and information about how that value changes. The initial value is always considered the value of b, because if you recall, b is really corresponding to the point 0b. It is when x is 0, so that's why we say it's the initial value. And the information about how the value changes is the slope, because if you remember, slope is the change in y over the change in x. So that's how we know those two values. And then, since we will know from the problem the value of b and the slope, we can just plug into the equation that is the slope-intercept form to get y is equal to mx plus b. So let's look at an example. Let's suppose that the cost to rent a car for one day is a flat fee of $15 plus 25 cents per mile. Write a linear equation for the cost y if x miles are driven. So from the problem, we're asking ourselves, what is the initial value and what describes how that cost changes? Because if we're looking at slope as change in y over the change in x, we're really trying to find out the change in the cost by the change in the miles driven. And we were told there that it changes 25 cents per mile. So that is our slope. So the 15 represents the value of b, since that's the cost to rent the car even if it's not driven, right, for 0 miles. 25 cents describes how the cost changes for each mile that the car is driven, and hence represents the slope m. So we have everything we need to put into the equation. It is just y is equal to 0.25x plus 15. Now understand, the 0.25 had to be converted to the dollar amount, right? 25 cents is equivalent to $0.25. So we had to have equivalent units listed there. Now, the second type of problem is the one that can be a little bit trickier. It's given two data points, and those data points are not always given in terms of ordered pairs. You might have to get that from the problem. But you're given two different criteria for which you can form those points. So the goal here is to find the slope of the line, just like we did whenever we had just random points that had no meaning. We had to find the slope first, and then use one of the points together with the slope to get the equation. So let's look at how an example of that would play out. Let's suppose the enrollment of Georgia Perimeter College was $15,000 in 1998 and $22,000 in 2005. We need to write a linear model that expresses the enrollment y in terms of x years after 1998. So we're given two criteria, right? We're told 15,000 in 1998 and 22,000 in 2005. Since we're trying to write ordered pairs that correspond to that, we need to write the ordered pairs in terms of x comma y, where x is the years after 1998, and y is the enrollment. So we've got to convert that information into that type of ordered pair. Well, since we just said x is the years after 1998, the year 1998 has an x value of 0, right? Because 1998 is 0 years after 1998. And the y value for that particular year was 15,000, so we know that's one of our points. But going on to find the other x value, the year 2005 has the x value of 2005 minus 1998, right? Because here we're trying to find how many years after 1998 is 2005, so we subtract off that base year to get 7. So the two given data points are 0, 15,000, and 7, 22,000. So now this looks just like any of the other problems we're dealing with. we have to find the slope. Remember, slope is y2 minus y1 over x2 minus x1. So plugging that in, we get 22,000 minus 15,000 over 7 minus 0, which simplifies to be 7,000 over 7, or 1,000. Now, to find the value of b, remember, if one of your points involves an x value of 0, you actually know the value of b. And that was our case. We had a point given that was 0, 15,000. So that tells us this is the value of b. It was the initial enrollment. And so we could get our equation just by plugging in the value of the slope that we found and the y-intercept value, which was 15,000. So y is equal to 1,000x plus 15,000. Now, what if you didn't recognize that value of b was right there in front of you? You don't need to panic. You can use one of the points with the slope to find the value of b. And remember how I like to use the slope-intercept form. You could use the point-slope form here as well. But if I know one of the points is 722,000, or you could have used the other point, it doesn't matter, and the slope is 1,000, we plug into the slope-intercept form, y equals mx plus b, and that gives us 22,000 is equal to 1,000, which was our slope, times 7 plus b. Now we multiply on the right. 1,000 times 7 is 7,000 plus b. So to isolate b, we will subtract 7,000 from both sides to get exactly what we thought. Y is equal to 1,000x plus 15,000. Now, you should also be able to interpret the values of m and b. And when you're interpreting, you're coming back to the meaning that b is an initial value, or the value when x is equal to 0. M describes how the y value is changing for each change in x. So in that previous problem, when we looked at y is equal to 1,000x plus 15,000, these 1,000 and 15,000 numbers should have some meaning to you. So we know that 15,000 is the initial enrollment, or that is the enrollment in year 0. But year 0 was 1998. So we could say it's either the initial enrollment or the enrollment in 1998. And M describes how that enrollment is changing. Right, the 1,000 over 1 is change in enrollment over change in year. So the way we say that is that that fraction tells us that the enrollment increases, and that's because the slope is positive, by 1,000 each year. Now, if that denominator had been 3, we would say it increases by 1,000 every 3 years. So that's how you determine it. If the slope is positive, there's an increase in the y value. If the slope is negative, there would be a decrease in the y value. And that's the example that I have to show you here. Suppose the value of a car X years old is given by y is equal to negative 1,500x plus 25,000. And you want to interpret the slope and the y-intercept. So first we have to know what the slope is, right? The slope is a coefficient of x, which is negative 1,500. We can write that as a fraction. It's negative 1,500 over 1. So the slope is telling us here that the value of the car decreases by 15,000 each year. Right, the negative 1,500 over 1. Since our denominator is 1, that means every year that change will occur. Now the y-intercept, remember our equation, it was y is equal to negative 1,500x plus 25,000. So the y-intercept is this 0.025,000. So that tells us the initial value of the car. So we would say that the initial value of the car is $25,000. Now, let me show you another example. And I'm going to pull this example from your homework that you have in my math lab. Oops. If I can do that. Let me see here. Okay, it's not wanting to capture this. Try it one more time. Apologize for that. Okay. So this is number 3 in section 7.2 homework. So of the two types we've talked about, let's see what this one is. So it's saying for a family membership, an athletic club charges a membership fee of $139 plus $39 for each additional family member after the first. Let X represent the number of additional family members. Write an equation in the form Y equals mx plus b that represents the membership charge for the family. So this is where we're given a flat fee and then an indication of how the fee changes. So here X is the number of additional family members. And Y is going to be the membership fee. So to write it in the form Y is equal to mx plus b, well, b is a fee that is charged regardless if there's any additional family members. So b is our flat fee, which is $139. The 39 tells us what the charge is for each additional family member. So it's telling us the charge is increasing, right? So it's 39x plus 139. I don't have to put over the 1, even though that's really what it's saying, that it's increasing by $39 for every family member that we add. So it's sufficient to put y is equal to 39x plus 139. Okay? You have one that's kind of like the one that I did earlier about the cost to rent a car. Okay, here's a problem that we'll do. It uses a graph to kind of display your ordered pairs, but it's basically the thing that we have talked about. So if I can capture this here. Okay. And I apologize, I forgot what number that was. That is number 5 from your homework. Okay. So the bar graph shows the number of post offices for the years 1981 through 1987. Let x equal 0 represent year 1981, and let y represent the number of post offices. Write an equation of the line in slope-intercept form. So we have to find 2 points first. Since we are given the fact that x equals 0 represents the year 1981, x really talks about the years after 1981. And then y is the number of post offices. So one of our ordered pairs is 0, right, that's the year 0, and there were 29,671 post offices then. And then the other one is 1987. How many years after 1981 is that? Well, if we subtract off 1981, we get 6. So our other ordered pair is 6, comma, then there were 27,201. Okay. So since we're given 2 ordered pairs, the first thing we have to do is find the slope. So if you label these x1, y1, x2, y2, we would have 27,201 minus 29,671 over 6 minus 0. Okay. So we need to subtract these. Of course, I don't have my calculator handy, so we'll subtract it by hand. So what is that? 2,470 over 6. Oops. But my sign is actually negative, right? So I can reduce that down by a factor of 2, I know. I'm not sure that 6 goes into it evenly, but if I reduce it by a factor of 2, my denominator becomes 3. So 2 goes into that, negative 1235, I believe. So this is our slope. Now, if you pay particular attention to this problem, you don't have to do any more work, because remember what our equation depends on. It depends on the slope and the y-intercept. The y-intercept is at an initial value. So if we know that, we know our equation. Our equation is y is equal to negative 1235 over 3x plus our initial value, which is 29671. Now, if you didn't see that, you would have to plug into the point slope or the slope-intercept form to find this value of b. Okay, so that concludes my lecture on section 7.2. If you have any questions, you know to always contact me. Thank you. Bye-bye.